Gentlemen, welcome back to the shop. Man, you feel that? Cold as a horse heart. And I lost track of the days, so it might just be the Sabbath as well. So instead of working on the secret stuff that actually pays the bills, I'm going to shirk my responsibilities. We're going to have some fun. I'm going to take apart this meule à rectifier les matrices pneumatiques, which of course is not Chinglish, but Franderin. It's a horrible bastardized Chinglish French. What it is an air die grinder. This is a cheapo, $10. But it's a Dremel that actually has some balls. Now, I know lots of guys love Dremels. I hate them myself because they're all show, no go. All speed, no torque. Please send your hate mail care of the King of Random, YouTube, California, YOB1GO. The great thing about pneumatic tools is you get a huge amount of power in a very small package. So you see this die grinder, pneumatic, is roughly equivalent to this big electric die grinder. Again, not a Dremel, because I'm not a 13-year-old boy. Don't forget where to send that hate mail. Because it's pneumatic, the awesome thing we can do with this is we can tune this up, no problem, right out of the box, get way more power out of it just by messing with the airflow. It's all about the airflow. These die grinders are all about speed. When it comes to fluid transfer, speed is flow. So you're getting a bonus nachos twofer in this video, because not only are we going to take this apart, we're also going to tune it up. Look at this junk. This is the snap-on hose reel that you buy at Costco's. Just horrible junk. Snap-on. Ought to be ashamed. The licensing stuff is just rubbish. Anyway, gotta fix that. This is just atrocious. Here's the blister that popped here, and you can see the inner rubber is cracked right half in two. So I took another section further up the hose, and look at this. Look at that. It's all split, like got no give to her. It's like an old 100-year-old tire. I'm really more of the shy retiring type, but the old Crossgo is going to get both barrels right full of squeaky wheel. So I've had to fix these before, obviously, and I like the PEX crimp-on ones because they don't cut you open like a stuck pig. These ones are for welding hoses. I like these a lot better than the gear clamps, because the gear clamp always has this pokey bit here that's constantly cutting you open. And then so then what happens is, oh, I know, I'll fix that. I'll get some electrician's tape and tape it up, and they're safe as can be. Then you got this big old hemorrhoid blob on the end of your thing, and it's sticky and gooey all the time. It just, no es bueno. That's why I like these. I mean, yeah, when you got baby soft palm olive hands like I got, I mean, yeah, takes a little bit of high maintenance. Sundown, you better take care if I see you been creeping in my underwear. These are my nice Nypex nippers. Not just for farriers. Look at this. Son of a diddly mother trucker. Done popped a blister again. It just doesn't end. So yeah, awesome. That's going to leave me about 12 inches of hose on the reel, and a scaring the living shit right out of my 80-pound lapdog. Poor bastard doesn't like air hoses. Well, as luck would have it, I happen to have a decades-old air hose that doesn't have snap-on on it. And amazingly, as luck would have it, it comes with the Milton M style, which is the style I have here. Of course, these were all proprietary fittings in the Second World War, and everybody was trying to get a piece of the puzzle. So instead of having the same air fittings, now we're stuck with all these legacy fittings. There's like 200 different styles, and never works out that you got the right style, but for some reason this time it worked out amazingly. And yeah, I'm using the good stuff, thread sealed tape. It's Teflon tape. And Teflon tape works great on air fittings as long as you're not a goof. You know, there's going to be somebody out there that comments for sure, oh, you shouldn't use that because it mucks up your valves. Well, you're a goof. I've been using this forever. It works great. You just don't put a whole crap load on there and then, you know, don't let it get into stuff. You're fine. I prefer the Teflon tape on air fittings. It seems to leak less than the pipe dope. I got it hooked up to regulated 50 pounds of air. And we got the gauge in there so we can see what the pressure drop is across the line when we're flowing, and yeah, just for shits and giggles, it's nice to see what the pressure is. And I ran it briefly and I got super sketched out because it was weeble wobbling all over the place, and now I see why. Here we're checking the run out and we got 8 thou a run out. This thing's supposed to run at 25,000 ripms. Oh, apologize, not 8 thou, 200 microns. There's somebody, some fucking goof, oh, no, apologize again, some dude took me to task for saying thou is in thousandths of an inch because he prefers microns. So I promised him that I would use microns in the next video. What do you guys think? You prefer I try and make myself sound smart, like a know-it-all smarmy fuck with the microns, or would you prefer I use thou? You tell me, because I'm easy either way. So here we go, we got a regulator at 50 psi. Have a look at that. Duck. She's weeble wobbling pretty good there. And this has nothing to do with the price of tea in China, but goes to credibility. There's 4 thou on the collet nut. Well, let's just see if the factory gave us the gift that keeps on giving there, that grinding dust that seems to be ubiquitous in the cheapo offshore stuff. We'll clean that out. Okay, I see the trouble here. This isn't ground. This collet seat. It's just turned in the lathe. And it's got some Chaudat, factory Chaudat in there. Yeah, there's your trouble. Well, I done what I could. I removed the factory shmoo, but that lathe turned collet seat just is NFG. Ay, mas problema. My Digital Revolution choocher is no es bueno. It's kaput. It just doesn't end. So I guess this is my time to shine. We got to figure out another way to take the rip'ems. Okay, so here we got the Helping Man and surface mount inductor. This is just a coil, and we got a 1000 ohm resistor and a neodymium magnet attached to the chute shaft here. And I think the Helping Man is going to need some help here, maybe a double fister. And we'll see if it works, but if it does work, fuck. Sometimes I amaze even myself. Sidebar. That is what's known as hubris, and that is what makes it okay for you to laugh at me when the magnet flies off and turns my eyeball into a deflated bag of goo. Okay, so my thinking here is the magnet chooches past there, and it'll create a voltage spike, or current spike? Something spike in this inductor, and we'll be able to pick it up on El Rigol scope. Let's see if I'm correct. Oh yeah. Definitely something going on there, but I need a third arm. Okay, I grew my third arm. Now let's get her chooch properly here. Something's coming in range. Oh, here we go, here we go, here we go. Check it out. Perfectly uniform pulses. So we measure the pulses and the distance between them, the time, we'll be able to calculate the rip'ems. Ha-ha! Crazy like a fox. Okay, so we're gonna set the trigger force 1 here. Say there, and then we'll back out the time base. Way out. 50 seconds? No. 10 seconds? No. 5 seconds. Now we'll do a single shot. And then we run the thing and see what happens. I got more than my safety squints on. I actually have my safety in my glasses, so hopefully you won't be able to laugh at me when my eye all blows blue. Well, clearly she's unchooching. What the fuck is going on, for fuck's sakes? Ron. So remember hubris? Yeah, not that bone in your leg, but the karma only, not as hipster douchebaggery. Yeah. There's your trouble. There's your trouble. Alright, there you go. Ta-da! Okay, so we know the period now is 5.3 milliseconds. That's 1 over 0.0053 seconds. And 1 divided by... Yeah, that's... No, I give up on that one. That's... Division's real hard. It's easier to do an exponent and multiply by a negative exponent, but that's beyond me. We'll go frequency, 189 hertz. So that's rotating 189 times per second. We want rotations per minute. So multiply that by 60. We'll go 200 times 60 is 12,000. Within 5%. It's going to be closer to 11,000 RPM, and that's at 50. So let's up it to the rated 90 pounds per square inch at the inlet and see what speed we get. So as we increase the pressure, we're going to get more flow to this. It means it's going to turn faster, which means more centrifugal force. That's right, I said it. And Mama didn't raise no fools, so old piece of plywood, pretty much the only thing wood's good for. And because this whole thing is cobbled together, kind of sketchy with that magnet on there waiting to fly out and kill us. We're going to use the old HPHT, tape down the trigger, and then slowly increase the pressure at the valve from a safe distance at a medium pace. Well, I got the old stand down from the better half. Chickadee's taking a nap, so you guys waiting for me to bust an eyeball will just have to wait a little while longer. Well, intermission, I can't hardly wait. That's my favorite part. So as you can see, I don't even have it apart yet, but we're going to do the intermission now. I don't know if the video will be long enough, but you guys have really come through. I'm blown away. Thank you very much. I couldn't possibly drink $400 worth of beer in one sitting. We're almost into the hookers and blow zone now. So come the end of the month, when the pledges actually come through, we will have a little war chest there to do some fun stuff. And no, I didn't drink her all SD. I think justifiably I feel beholden to you guys that are helping pull the cart, because now it's like, well, I can't let them down. And that's probably a good thing, because I don't want to be that guy. You know, the fucking guy that asks for shit all the time, and then, you know, I don't want to be that guy. But thank you very much. So the guys that are interested in helping make these videos and do contribute a couple bucks to Patreon, thank you very much. Of course, if you have your own channel, please let me know so that I can give you a shout out and people can go and check out your channel as well. Of course, you got something special going on, you want your name up in the credits, or you want a special greeting, let me know. Not a problem at all. My pleasure. And I'm coming into super busy time of the year, busier than a dog with two dinks. I mean, hair straight back. And the Patreon actually is really helping out, because guys are asking a lot fewer technical questions. Like, I get a lot of PMs about which saw should I buy, I need to fix my chucher, blah 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 blah. But with the Patreon, it's like I get a lot of hydraulic questions too. But with the Patreon, it's like, oh, I didn't throw $2 into the hat, maybe I shouldn't ask the question. So it's actually been really awesome that way. And I make an effort to answer everybody that asks a question. Even if I can't answer, I still answer. And that's, of course, because I enjoy answering questions. If I didn't enjoy it, I wouldn't do it. Same as making videos, same as doing teardowns. If I didn't enjoy it, I wouldn't be doing it. Well, Tempest Fugit and so forth, on with the show. Well, sure, I'm glad I put up my blast shield, because this thing spins thusly, contrary to the way that I put the tape on. It scared the ever-living shit out of me. I would change my drawers, but it's laundry day, and okay, I had her up to 90 psi in the tank just prior to having a HPHT failure. So we'll see what that speed is. You can hear it coming up to speed. There's a real spot where the harmonics kick in, and it hits a speed wobble there. So I try and tweak it past that real quick. So that was pretty neat, because we had it at 100 psi on the regulator, and we were only getting around 70 psi on the gauge right at the inlet. That means we're dropping 30 psi in 50 feet of hose. You can imagine you got a whole shop right full of lines and stuff. You set the regulator to 100 psi and you're running some tools, you're not going to get actually that many psi at the tool. There's a lot of line loss. So that line loss is a real killer, because you can spend $500 on the top of the line half-inch impact gun and it won't hit for shit, because you're running it through, like, it's starving for air. So you really got to be cognizant of that. And on the other side of that is you can get a lot of performance boost out of your air tools just by using bigger lines, shorter lines, less restrictions. Well, surprisingly, well, like the other guys that do tool reviews, it doesn't feel so bad in the hand for $10 actually. And it's got a nice, I would say that silicone carney boot. It might be urethane. Quick way to find out. Fire up the old Rigol. We'll bring her up to, say, 450. 450 will destroy urethane, but not silicon. Urethane, I think, can withstand something like 300 degrees F, and silicon can do more like 600. And even 300 melts it, so it's a real soft durometer urethane, not silicon, so I was wrong. So that's not good. Interesting story. Snap-on, when they first started coming out with the urethane handles on their air tools, they did it on the palm sanders and stuff for bodymen. Of course, bodymen don't use any lube in their tools, because one little drop of grease or oil on a prepped surface and the paint job is completely ruined. So then when the actual mechanics started using, of course, they grease the hell out of everything, lube it all the time, you know, follow the instructions. And these boots were just turning to shit because the oil was attacking them. There was a huge recall. They had to fix a lot of tools. And looking at this, pretty funny. This isn't bad, like, it's pretty skookum. But if you look at this, the rubber is catching here, and you're not actually actuating the valve all the way. So an easy way to get probably more performance out of this than you care to shake a stick at is to take this boot off, and then the valve would actuate better. Of course, if you take the boot off, then you run the risk of your hand freezing to it, because it does get cold, right? All that air flowing through it. That's pretty brutal. You can see by eye that's off by almost 200 microns. Brutal. Just taking this gland out here. And the gland, actually, the machining's not that bad on it. There's a cast part here with this little Maltese cross for some reason. I guess just to save on material. Instead of making that solid, it's just bearing on these 4 little points to retain the motor. And we'll get a clean rag out. There's a big burr there on the porting, just ready to fall in and destroy the vanes. This is a 652Z bearing, little tiny guy. Well, I got out the old jeweler's hammer, and it's a little more brittle than I expected. I done fucked her. I think this is a pretty good time to tell you about the prime directive. And the prime directive is, if it ain't broke, don't fix it. So the only reason I'm taking this apart is just to see how it's made and to make a video. Otherwise, I would leave it alone. So let that be a lesson to you. If you're going to take something apart, like if it's already fucked, well, you're not going to hurt anything because it's already broken, so you're going to break it more, who cares? There we go, rookie mistake. Friggin' rank amateur. I should have gone at it with the backside, but I mean, realistically, these are disposable. I'd be surprised if anybody takes these apart to fix them nowadays. And what we have here is a 4-vane motor. And there's no intervane in here, so it's a low pressure vane motor. If this was hydraulic, they'd have a cutout here, and what that would do is reduce the back pressure on the vane, because obviously if you got, say, 3,000 psi and it's pushing on a vane like that, you got a hell of a lot of force. Whereas this, you know, you're running 100 psi, it's no big deal. And these are some sort of epoxy fiber reinforced little plasticky vane. This is common wear ring, or some people call them bearing material in hydraulic pistons. And here's the body of the motor, and something interesting going on in here. Really no good. Ah, there you go. See that little sparkly bit? So there's already 2 spots that are all galled up. This is aluminum, and there must have been something in there right from the factory, and they're all chowdered up and galled in there, flattened over. So considering this thing turns at 25,000 ripams, this motor is not long for this world, even before I messed it up. And this front bearing is a little bigger than the back bearing. It's interesting because it's a 608Z. That's a skateboard bearing. And the Z says that it's single shield. Now there's one shield, but because I broke this, we can see it's also shielded at the back. So either I got my nomenclature wrong or they did. Because 2 shields I would think would be ZZ, and then sealed would be SR. So here's the body of the thing. You can see lots of porosity in the casting. Just pretty horrific there. Not a single fuck given. And we got the ball bearing shield in the back. Now we're just taking out the back side of the valve plug here. See what's in there. And a lot of times on hydraulic or pneumatic tools, when they run all the time, there's some shmoo that got in this valve. So you just got to pop this out and clean the shmoo out. Of course, the valve is a pipcack. It's between the steering wheel and the driver's seat, so it takes the brunt of any stupidity, and it's always what fails first. So this is interesting. They got a Buna end seal on the top hand here, and then on the bottom wise, they got a Viton, looks like. And I'm assuming that the the Buna end, of course, is cheaper, so why they go with the Viton, I have no idea. But I think the Buna end is more pliable as well. And because this is an air tool, it gets cold. Bernoulli's law, thermodynamics, blah, blah, blah. That pressurized air that's going from a pressurized zone to expanding to its full size at 0 pressure cools everything down at the outlet, and everything gets cold. So you'd think you'd want a more pliable O-ring, not less. So unfortunately, I don't see any way to port this because this is injection molded. This plastic is injection molded right into the body. So in order to get that out to do the porting, you have to wreck it. Of course, we don't want to do that. Now this is interesting how they've done this. Like, how do you get this together? Well, this is a separate piece from this, and then they've gone and not swaged, but just heat shrunk that on. So that's just a friction fit, which is fine. I mean, heat shrinking, it's stronger than welding in a lot of cases, but you can never get this apart. That is to say, you're going to have a hell of a time getting it apart. So I was just looking at this to see if the damage I caused was hopefully on the outlet port side, and unfortunately it's right on the high pressure inlet. So that's going to be a tough fix for sure. And you can see here the compressed air comes in on the small side and goes to the lower pressure, so it's going to make this turn, and as it goes it gets lower and lower pressure till it exhausts. Here's the inlet plate that goes at the back of the motor and allows air to get in. So this is where we would crank this up. You see how small that is and how small this gallery is. Be nothing at all, easy peasy lemon squeezy to open this up just with another die grinder, or God forbid a Dremel. Well, we got the patient in the vise here, and it wouldn't be right if we didn't try to save it, so we're going to try at least, and use some silver solder, and I'll just chooch that in there and flatten it out and see if that does the trick. So whatever this pot metal is, it does not want to take the silver solder. Can't say we didn't try. Well, that's a crying shame. I don't like messing stuff up. I don't mind messing stuff up when it's on purpose. When it's by mistake, kind of stings a little bit. Hurts me right in the hubris. Son of a diddly. Let's never speak of this again. I'll likely get over it. Thanks a lot for watching. Keep your stick on the ice.